The independent samples t-test has two variants of that, okay? There's variant 1, where we assume the samples have been drawn from populations that have equal sample variance. So where we assume the samples have been drawn from populations that have the same variance, that have the same variance. That's the first version of the the first version of the independent samples t-test we could perform. There is another version of it, okay? Variant 2, okay, where we assume that the samples have been drawn, from populations that have, so I'll just do ... we assume the samples have been drawn from populations that have different variances, okay, different variances. Now, in this particular scenario here, the examiner, okay, or the person, Stephen, who set this particular scenario, has told us to assume the population standard deviations are equal but unknown. Okay. Now, what we'll actually assume here is, don't forget, the variance is the square of the standard deviation. So what we're just going to take another little bit of a leap of faith here. We're going to assume that the population variances are in fact equal, okay? Because that dictates they're the two types of t-test that we can actually undertake. The two types of independent samples t-test. One where we assume the variances are equal, are the same, have the same variance, okay? And the other where we assume that they have different variances. Now, in this case here, Stephen is telling us to assume the population standard deviations are equal. So the type of t-test that we're actually going to perform is variant 1. Okay. Now, just to keep in mind, we actually have a set of tables that we provide to our students. These tables give us all of our test statistics, and in this particular instance here, we have a test statistic that we can use for. It's a test statistic for a test of the difference between two population means, where we assume sigma is unknown. In other words, the standard deviation is unknown, but they're assumed to be equal. So in this case here, we're assuming that the variances are the same, okay, or the standard deviations are the same. In which case, our test statistic looks something like this. The test statistic, okay, that we're going to use, okay, the test statistic. Okay, it looks something like this. Let me just do this. It says that t is equal to, it's the difference in the evidence, okay, so it's x1 bar minus x2 bar, okay, and it's how far that is away from the difference in the populations, okay, so it's mu1 minus mu2, okay, all divided by a measure of what's known as the pooled variance, okay, so it's SP squared, and this is the pooled variance is different to this prime land, maybe I should actually call this SP small r here, yeah, so that's not, we're not confusing this SP with this pooled variance. So the test statistic is the pooled variance over the first sample size plus the pooled variance over the second sample size, and it's the square root of that particular measure here, okay, where this pooled variance, if we want to calculate the pooled variance, where SP squared is simply equal to the first sample size minus 1 times the variance of the first sample plus the second sample size minus 1 times the variance of the second sample divided by the sum of the sample sizes n1 plus n2 and minus 2. That's our degrees of freedom here, okay? So maybe I'll write that down as well, where the degrees of freedom for the test, since it's a t-test, the t-distribution is parameterized by the degrees of freedom. The degrees of freedom is n1 plus n2 minus 2, okay? So this is our test statistic, and so don't forget, the test statistic is a measure of how far the evidence is away from our hypothesized position of our distribution. Now, in independent samples t-test, the sampling distribution is a sampling distribution of the difference between two means, okay? So you can see this mu1 bar, this mu1 minus mu2, that's a difference between two population means, and then we have the evidence, which is x1 bar minus x2, that's the difference between the evidence. So the question is, from this t-statistic perspective, is how far away is the difference between the pieces of evidence away from what we would believe the difference between the two populations should be, if that makes sense. Okay? So, to undertake this test, what we need is x1 bar, x2 bar, we need n1, we need n2, and we also need a measure of the pooled variance. And the pooled variance is got from the variance of the first sample and the variance of the second sample, and also their respective sample sizes. So actually, we're provided with all the information, albeit we've been provided with the standard deviations here. Okay, so these are standard deviations. So don't forget, they're standard deviations. Standard deviations, where we need the variances. So the variances are going to be the square of these particular values. Okay, so they're the standard deviations. Maybe I'll just circle that, put that in red here, because that's important to know that we've been given the standard deviations and we haven't actually been given the variances. Okay, so we've been given 2 standard deviations. So let's undertake this particular test, and once again, anytime we're doing a hypothesis test, okay, what we should do is extract out all the information that we're being provided, and then we start the test. Okay, and as I've said before, there's 5 steps in this particular test. Okay, so there's 5 steps. The first step is to define the hypothesis. So here's our hypothesis test. Our hypothesis test. Okay, and what we're going to do now is we're just going to define the hypothesis. Step 1 is the hypothesis. Okay, the hypothesis that has a null position and it has an alternative position. Okay, and don't forget, anytime we do a hypothesis test, if we do want to make an inference, the only place we can make an inference is, the only time we can make an inference is when we reject H0 in favor of HA. So what we want to try to prove always has to be our alternative hypothesis. Now, let's have a look at the last paragraph here. It says, test at the 1% level of significance. Actually, so we know also the significance of the test. The alpha level should be 1% or 0.01. But what do we want to test? We want to test at the 1% level of significance the proposition that the average household income in County Primeland is higher than that of County Rockland. Okay, so well, what's the average what's the population average for Primeland? It's mu of p. Okay, and what we'd like to test is to see whether mu of p